Okay, guys, so here's the A dash. Oh, this should be 10 actually. I just did 9. Shoot. That's the A dash 10 video. Whoopsie. Okay. So, yeah, I think in our document, I think I put 9 there instead. Alrighty, so the directions here are find the limits by approximation without a calculator. Okay, so yeah, these should be pretty simple. All right, so number one, the limit as x approaches -5 from the right of x plus 5. All right, so it still does not hurt, guys, to draw like a little number line. And here's -5. So we're approaching -5 from the right. So let me do an integer to the right. So like -4 is here. So like a number very, very close to -5, but to the right is like -4 point. I'll go 99999. Okay. Yeah, so like imagine you're here and then you're just getting even closer as time goes on. All right, so like the way that you would do this, guys. So let me do like a little aside here. So this is like a little aside. All right, as x is approaching -5 from the right, my little aside is going to be like this. So this here, so what I'm dealing with is really about -5 plus 5. Okay. I guess you don't even have to do. I'm just introducing some notation. You don't have to even do this, guys. You could think it through a different way. But this little tilde means about. So if you've got about -5 plus 5, that is about, this is equivalent to about 0. That's equivalent to about 0. All right. So, yeah, and so you could think it through that way. So it's about 0 and continually getting closer to 0. So if something is about 0 and then it just keeps on getting closer and closer and closer to 0, well, that means that it is approaching 0. That means that the limit is 0. Okay. And also you could think of it this way, like if you thought of like x being -4.99999 plus 5, that's a super small number. And it just keeps getting smaller as you're adding more 9s. Okay. And this notation down here that I'm using, this about, that'll come into play later. Okay, now x is approaching 2 from the left. All right, so this time I could go like this. So here's 2. I'm approaching it from the left, so there's 1. So we're thinking about like 1.9999. Okay. Now another way of thinking about it, you could think of like x being 1.9999 and think it through like that, but this is also helpful, and this will be more helpful a little bit later. So aside. So I've got 3, and then instead of this x, I'll just think like about 2. I'm approaching 2 from the left, so that would mean that this x is going to be about 2 and then becoming even closer to 2 over time. So this is 3 times about 2, and then I've got about 2 minus 2. All right, so where the x's are, like where this x was before, I put the about what x is approaching. And where these x's are, I put the about what x is approaching, so the about 2. Now, let me think about this. Guys, this is, so 3 times about 2, that's about 6. So 3 times 2 is 6. So 3 times about 2 is about 6. By saying about, I mean approximately. No. That's approximately 6. This will take some getting used to, guys. Just, be patient with yourself. So this turns into about 6. And then this right here, about 2 minus 2. Well, 2 minus 2 is 0. So about 2 minus 2, approximately 2 minus 2 is approximately 0. Okay. So 6 times 0 is 0. So about 6 times about 0 is about 0. And by about, I mean approximately. So that's approximately 0. So guys, if x is approximately 2, then this entire expression inside is approximately 0. Okay? It's approximately 0, and the closer we get to 2, the closer this expression gets to 0. So that is also, that limit is also 0, because this thing is approaching 0 as x approaches 2. Okay, guys, now this was just kind of building up to what we're doing later. This also is building up. So everything I'm doing is building up to what you'll actually be asked to do on the practice portion. All right, now, so more, I'm going to talk slow, guys. If you feel like you need to speed up the video, go right ahead. But I'm going to talk slow because these are kind of deep concepts. Okay, let me take a drink. Now, I'm about to represent a very small positive number like this. A very small positive number. Now, very small is different in different contexts, okay? Like if you're talking about a bank account, you know, a very small amount could be $10, okay? But in calculus, 10 is not a very small number. In calculus, you're dealing with a lot of infinites, things that are infinitely big or infinitely small. So if I'm talking about a very small number in calculus, I'm talking about a very, very, very small, almost infinitely small number. Indeed, infinitely small in this case, okay? Infinitesimal is what an infinitely small quantity is called, infinitesimal. So a very small positive number, I'm going to represent like this in a moment. I'm going to represent it as about 0, but positive. So I'm going to write a little POS there. A very small negative number, I'm going to say about 0 negative. So like an about 0 positive number would be like 0.0000000, you know, keep going 1. And then an about 0 negative number, we're thinking like negative point, you know, a bunch of zeros and 1. It's just a lot easier to write these instead of writing something like this and actually even more zeros we would want if we're at about 0. Okay, now for this next part, and this is still building up to your practice, still just building to what you'll be asked to do. So the directions. State whether the expression represents a very, excuse this, at first I said big, then I thought small, then I realized it was big. So state whether the expression represents a very big positive or a very big negative number. All right, so 7 divided by about 0 positive. So 7 divided by about 0 positive. Now, eventually, guys, we don't want to use our calculator, but you can use your calculator. I mean, if you're super stuck, if you can't imagine this, then use your calculator. So like 7 divided by, let me do a number that's about 0 but positive. So like 0.001 I'll start with. Oh, that's pretty big. Now let me get even closer to 0. So 7 divided by, so even closer to 0 positive, 0.0001. Even bigger, 7 divided by 0.00001. Even bigger. So guys, this is a very big positive number. Okay, so I'll say very, yeah, let me write this. So very big positive. That's a very big positive number. And guys, another way of thinking of this, if you've got like like 7, in terms of calculus, 7 is not a very small number, okay? So you've got a not very small number divided by a very small number, okay? So if the denominator is much, much smaller than the numerator, that's going to be a huge number, actually, okay? And then these are both positive, so a positive divided by a positive is a positive. So that's why we've got a very big positive. Now this one. So this is -9 divided by about 0 positive, but on the positive side. So this time we've got a negative divided by a positive. So a negative divided by a positive, we know that we're going to end up with a negative number. And now let me just for effect, let me show you -9 divided by 0.00001. So that's a very big negative number. So very big negative. And again, if you didn't use your calculator, a negative divided by a positive is a negative. So I'll say very big, VB negative, very big negative. Now this one. So we've got -5 divided by 8 times about 0 negative. Okay, about 0 negative. So what this is, guys, this is -5 over. Now think about this. So 8 times about 0. Okay, so 8 times 0 is 0. So 8 times about 0 is about 0. 8 times a super small number is going to give you a super small number. So we've got this super small number, about 0, but whenever you say in calculus about 0, you want to be thinking of, if we're about 0, we're not exactly 0. So you're either on the you're either on the negative or the positive side of 0. So so now you want to think like in terms of deciding whether this is on the positive or negative side of 0, you want to think about, I'm just thinking about how long this video is becoming, I'm sorry. You want to think about like positive times negative. So positive times negative is negative. So this is still going to be negative. So we know this is going to be a very big number since the denominator is so small relative to the numerator. But now, okay, so we've got a negative divided by a negative. So that is, again, a very big positive number like the first one. Okay, guys, now let's do this one, and then I'll stop the video and I'll do the rest of it. We'll do the rest of it tomorrow, actually. Okay, so this one, we've got -2 divided by -4 times about 0, but on the negative side. So this is very similar to the one that we just did. So this is going to be -2 over -4 times exactly 0 is exactly 0. So -4 times about 0 is about 0. But a negative times a negative is a positive. So this is about 0 positive. So we know this is a very big number. So it's a very big what kind of number? A negative divided by a positive is a negative. So this is a very big negative number. Guys, I will do this lesson in 2 parts, so you don't have to watch a super long video. Deep concepts kind of, guys. So I had to really like take my time with it. So I hope that made sense. Let me know if it didn't.